time. Now, something to keep in mind as we're talking about this, remember, this is a regression line for an individual kid. It's not anyone else's. It's not based on anyone else's data other than this one student. It's their individualized, personalized kind of growth trajectory that we're seeing, just for them. But what about other students? Maybe, and notice now I'm kind of dropping off the individual data points and just showing their regression line. What about if I go and gather data on some other student? We could look and say, okay, well, here's some other student, this red line, that looks pretty different from the first student. And again, we calculated a regression line for that second student exactly the same way. We just looking at her data, we're looking at how did she do at those 5 points in time, and we plug them in and we calculate the intercept, we calculate the slope, we get a nice kind of, in this case, flat line for them. And that naturally then leads to, okay, well, we notice this kid's starting off low but showing a lot of growth. This kid's starting off higher, kind of not showing as much growth. That's interesting. You know, why? Are there things about the students, things about the kids, the participants, the subjects, whatever we want to call them, that might explain, are there child characteristics? Now notice, now I'm not talking about individual points in time. Are you tutored? Yes, I'm not tutored. I'm tutored. I'm tutored. You know, we're not looking at things that vary over time, because now we're looking at two different lines, and each line represents one child. So now we're asking, are there fundamental child characteristics that might explain why she's way up here and he's down here? Gender might be one that might explain it. And we get child level data. And so notice it's kind of that fundamental child characteristics. And that's where I'm trying to draw the distinction. You can have data for a child that varies at each point in time. Are you playing a sport this month? Yes, yes, no, yes, yes, no, yes, no, no, no. Changes over time. Or there's a characteristic about the child that doesn't change. My parents graduated college. My parents graduated college. My parents, they graduated. Their education didn't change over the course of a year. I'm male, doesn't change over the course of the year. I'm, something that's that fundamental who you are, your race, your ethnicity, something that's constant about the child. Because again, we're looking at these lines which reflect the whole child.
Are those child level data always like continuous, or can they be continuous?
It can be continuous. It can be what's your family income. Now that may change over time, so that may be, depending on how long your study is, that might be something that isn't changing now, may be something that you do look at changing over time. I mean, you'll see studies that you often will use, well, what's the family's income level as that family characteristic, and high income, low income. Well, that's actually, let's look at this here. So one thing we might look at in this case is, sure enough, we see that, well, this student is low income, they may be free reduced lunch, whatever, and that student's higher income. So maybe that's part of what's explaining it. And we'll assume in this case that doesn't change, because we're looking within a time frame that we're not expecting it to substantively change, and we just say, okay, whatever your SES is at the beginning, that's what we're going to assume and kind of work with that. But again, if you've got something that's 5 or 10 years long, then you may treat income as another one of those time varying sort of variables. So it kind of depends on the situation, on the nature of the study. But again, for us, it can be continuous. It doesn't have to be dichotomous. But yeah, it could be anything. So we look at this and you might think, okay, well that kind of makes sense. I can understand that maybe lower SES kids are starting off lower, and it's nice to see they're starting to catch up with the higher SES peers. That's kind of a nice, equitable sort of educational setting that we might like. We might see that maybe SES explains differences in those intercepts. Notice how I'm framing the question. There's one question. We could have multiple. One question that we may kind of come out of this is, does SES, yeah, look, there's a big difference here based on, at least on an N of 2, but the low SES child has a much lower intercept. They're starting off much lower. That baseline performance is much lower. And another question might be, and notice the slope for the high SES kids almost flat, where the slope for the low SES kid is much more positive. So SES may be related to their intercept term, kind of where they were at the start of the study. And it may be related to their growth over time, and how big that slope is. Now, of course, this is an N of 2, so the natural question is, well, what about if we did this exact same study or not study, we do this exact same process with more kids? And again, what we're doing is we're saying, I'm going to get 5, I'm measuring, everyone's assessed 4 or 5 or whatever times. And I'm assessing, I go get your data and come up with a regression line just based on you, no one else. And I can get your data and make a regression line just based on you. Everyone's getting their individualized, personalized little growth model.
So it's not the group as a whole, it's individuals within the group.
At this point, it's individuals within group. What's really nice about this, because we're looking at kind of these regression lines now. Notice I'm not looking at individual points, but we're talking about the lines. We can have different numbers of assessments. Maybe this child had 5 assessments, and this one, the red line, had 7. That's okay, because in the end, what we're really asking about now is, well, what's their intercept and what's their slope? So HLM, part of the big attraction for this sort of data, is it's flexible for when you are missing data. You can calculate a slope based on 8 data points or 6 data points or 4 data points. You can be missing data along the way and still estimate what's that trajectory they're on. What's their predicted intercept value? If you're doing longitudinal research where you're assessing kids multiple times, we did, I think my biggest study with early in my career with Shaniqua Walker, my first graduate student, I think we had 8 time points. We were measuring kids 8 times. You're never going to get, and we were doing it in school. How many kids are showing up every day 8 times? 8 times over the course of a year. If you have to drop kids who are missing data, that's the real problem. So this kind of a strength of this approach is, yeah, you can handle missing data much more easily than if you did this using other techniques. Like we haven't talked about repeated measures ANOVA. Is more cumbersome, more problematic if you have missing data. Kind of one of the beauties here is because we're looking at their slope and their intercepts, that's okay. So as I was saying, so we calculate a regression line for one student, we got a regression line for another student, and we go out and get, let's look at all the students in the school. And we color code them based on, are they low SES or high SES? we start to see a pattern. Each of these lines is a different student, their own individual growth, their own individual little trajectory that they're on. And if you look at it carefully, you start to see, well, one, they are kind of all over the place. That's not surprising. That you see kind of lines crossing. Generally, they're going up over time, but not all of them. There's a couple, if I had my wand, I could point. There's a couple you can see the kids actually go down over time. That's a bummer, but it happens. On average, they're all going up. We also see that if we kind of look at these intercepts at the beginning, it looks like we got a lot of blue down here, the lower income kids, and more of the higher income kids at the top. That's kind of consistent with what we saw. Now notice, of course, there are some high income kids that scored low at the intercept. And there's one kid up there, gosh, looks like almost the top performing kid is a lower income kid. So there's variability. There's variability in what we're seeing. But we see a kind of this trend that there's lower income is starting off lower, and the higher income is starting off higher. And if we look at the slopes, we look at the high income slopes, all those red lines are pretty flat. In fact, that's where we see one of the negative ones, that the top red line is going down over time. Otherwise, they're going up slightly, but they're pretty flat slopes. Versus the blue lines, the lower income kids are all showing much more accelerated growth. So that's another difference. We're able to start to understand at a conceptual level right now. We haven't talked about how we would analyze that, but at a conceptual level, we can start to see that, well, if I've got these individual regression lines for every kid, and so every kid's got their slopes and intercepts, some of the intercepts are related to, are you lower income? Are you higher income? The slopes are related to, am I lower income? Am I higher income? These child characteristics are going to be seem to be related to their individual regression coefficients, their personalized regression coefficients. Now, so if we look at all the students in the school, we can then go through, now we can come in and say, okay, let's take the average for the whole school. And we'll look at this school average. And it's this big black line that goes right through the middle. And that's kind of the aggregate across all of the kids we see for this school. You know, on average, you're starting here, and we're seeing some positive slope over time. That's the school average. And we can have a regression equation for this school that says, what's the name? Abraham Lincoln High School or middle elementary has their intercept is this, their slope is that, you know, over time. And so the school, just like the child has their own personal, your regression model, that's your intercept and your slope, the school can have its own regression model, which is the intercept for that school and the slope for that school. And we can kind of get rid of all of the other variables.